So the last video called "Fail Over Succeed" or "Success" is the name of the actual file is definitely different than the title because I changed the title. But normally when I create a video, the first thing I do, okay, um, and this this habit started many years ago. Because nothing's more annoying than spending an hour to create a video and the microphone wasn't on. So I always do testing, okay, and make sure, kill the video, replay it, and make sure that I got sound, okay, all right. But this morning I was like, whatever. I mean, it wasn't a thought. I just started recording, and when I just at this moment, about 160 seconds ago, I had picked up my headphones and immediately went to go power them on, and I was like, wait a minute, hold up, did I even have them on when I actually did the last video? And no, I didn't. So there's no sound. So I'm going to delete that video. Hang on for a second. I had to put my glasses on. Another reason why I hate wearing headphones. Okay. But nonetheless, la, 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 la. So now I have to go back and delete this video. Okay. So yeah, my bunny video there. Yeah, something about it getting a rabbit, but not sure. Uh, okay, so this needs to go bye bye. Boom. Oh, I don't even know how to delete the damn things. More options, delete forever. There we go. I understand. See ya. Okay, so I apologize for that. All right, so now what we're going to do after our topology is created, okay? We're gonna maximize that, okay, and kind of bring this up a little bit closer, okay? Bring this all the way over here, and bring this up, and we're gonna log into our ESXi server. Okay. Now we have to understand that these VLANs, VLAN 2, VLAN 4, 5, which is incorrect, um, which doesn't really matter. I don't know where happened to 3. Oh, okay. So I mistakenly made this 3 when it's supposed to be on 2, and I never updated these. Okay, so which doesn't really matter, but it kind of matters to me. But it ain't really that big of a deal. Okay, as long as you're following the diagram, because the diagram is there to limit, first of all, to get your idea on paper, but also at the same time to limit mistakes. Okay, even in production. Okay, I mean, guys, having a visual outlook of what you're creating, okay, all right, this limits mistakes, okay, because nothing's more. And I'm gonna tell you, when you first start, you build your lab, okay, you write all this out on paper or Visio, okay, and you don't use the diagram to build your physical topology, okay, as you're cabling things up, okay, whether it's a virtual device or whether you are physically using cables on physical equipment, okay, all right, 9 times out of 10, all right, your topology on a layer 1 perspective is going to be broken. Now, if layer 1 is broken, how are you ever going to get layer 2 and layer 3 reachability? You cannot. Okay? All right? Now, so limit your, not to mention the fact this is such a great behavior aspect, or I don't care if you call it a behavior byproduct, okay? But I don't troubleshoot even 2 devices without creating a diagram, even if it's just on a pad and paper, okay? All right? Because I don't want to have to do a show IP interface brief every time to find out what the IP address is. It's on paper, Okay, so remember that these VLANs, VLAN 1, 2, 3, and 4, they are not VLANs. It's not a Cisco switch. It is not a switch that we're connected to. Okay, it's a virtual switch from ESXi's perspective, but it literally is just a naming convention. That's how I am using it. Okay, so let's go over to configuration. Okay, and networking. All right, and now this is the old ESXi. Okay, all right. So if you have like I think version 6 or higher, um, yours is going to be a little different, but it doesn't really matter. It's the same concept. Okay, so to keep this traffic, okay, from bleeding from one connection to another, because we are creating point-to-point connections, okay, besides VLAN 2, that's on a broadcast domain, all right, which technically VLAN 1 is on a broadcast domain as well, okay, because broadcasters are going to only hit the router 1 and router 2 on those G1 interfaces, okay, where on VLAN 2, okay, router 1 G2 can hit router 2, 3, 4, and 5 G2 interfaces on that same broadcast domain. Does that make sense? Okay. So a point to point means you only have one other device on the other side of that connection. Okay. Now, okay. So promiscuous mode is a concept of if you turn it on, okay, regardless of who is ever on that switch, even though you have separated it from a port group perspective, they're still going to be able to reach each other. Why you would have this as a option is beyond me. But that's again, that's the SSI stuff. That's that virtual crap that I don't deal with. So what I do with is I create because a virtual switch in ESXi cannot bleed into another virtual switch. That part is fantastic. Okay, so instead of creating port groups within one virtual switch, I create a new virtual switch. Okay, all right, for every connection I want to make. Okay, making it sure that it is a serious point-to-point connection. Now, within that virtual switch, like switch 2, I still have a port group called VLAN 2, but it's just a name. It's not a VLAN. Okay, all right. So from that concept, from that concept, lost my train of thought. From that concept, remember that these are names. Now, can I use these port groups as VLAN with VLAN traffic? Yes. Okay. If I actually went to this particular interface here, okay, on my ESXi server, which I have to actually do it as a physical be there at the keyboard and monitor of that ESXi uh, uh, server, okay, I can go in and change the VLAN of that interface to 4095, which, there is no 4095, but that tells ESXi that this is going to be connected to a trunk port. Perfect. So then I go on to my switch wherever that interface of the ESXi server connects to and make it a trunk port. And now these port groups, as I assign them to particular VLANs, okay, up, okay, see right here, VLAN ID, okay, that's 0, that means it's none, okay, if I change that to, okay, which we're not going to do all, okay, all right, if I say 10, okay, all right, now this VLAN ID is 10, okay, meaning that since I'm connected to a trunk port, okay, it's going to read tagged information. And meaning that any traffic that comes in here tagged with VLAN 10 is going to go to the port groups that are assigned to VLAN 10. Beautiful. Okay, that is awesome, and it is badass. Trust me. Okay, so you can do that, but that's not what we're doing here. These are just names. All right, I could have named this Kyle 1, Kyle 2. It doesn't matter. Okay, so now I go into CSR 1. Boom. I say edit, and then I go to the first network, which is G1. Okay, now, okay, if your configuration is not panning out, meaning that you connected network adapter 1 to a particular port group, but I can't ping the other side. 9 times out of 10, that's because adapter 2 is actually your G1. Okay, it's backwards. So all you do is delete them. Okay, so you don't have to figure out what the order is. Okay, and okay, just create new ones. That's how I get adapter 1 to be G1 and adapter 2 to be G2. Yeah, trust me, that's annoying. Okay, so now we're gonna put this on VLAN 1. Boom. Oh, I'm expecting it to pop up. Alright, let's just do it this way. Alright, VLAN 1. Alright, now let's go back up to 1 because G2 needs to go to VLAN 2. Okay, so that's done. Let's go here. Let me stop doing that. Okay, and this goes to VLAN 2. Alright, and no, that's gonna be this one. VLAN 2, 4. Alright, VLAN 2, and then 5, VLAN 2. Okay, so now let's scroll this over here. Boom. And bring this up and then slide this over here. So see, so I can see it. It's very crucial, very important. Now 5 also, the first one, that's going to go to VLAN 3. Remember, they're just names, they're not VLANs, even though I keep saying VLAN 3. Okay, so 6, G1 goes to 3, and then 2, oops, goes to 4. And 7 goes to 4. Okay, let's go back here to make sure I got that. Yes, nope, wrong. Okay, so I screwed that up. So, um, that's my mistake. So let's go here. This will be 2. This will be 2. Alright, save it. Go back over to here. I had G1 in there twice, so we can't do that. So go back over to 6. G1 is VLAN 3. G2 is VLAN 4, which I actually put it right in here. It's wrong on the diagram. And then here, okay, so now, anytime you're doing something like this, you always got to have a port group name, okay, that you're not going to use, like home network, okay, all right. I'm not using that, but that gives me the ability, okay, to eliminate a interface outside a particular port group name, okay? Because you can put it in home network, all right? Otherwise, you're going to have both interfaces in that same name because you can't put nothing in there. Does that make sense? Now, when you create the actual device until you put it an interface in the port group, it is set to nothing. But once you set it to nothing, you can't unset it back to nothing. Not that I don't think so. Anyway, so let's go here. Yes, I don't have that option. These are the only options I have. Okay, so without home network, okay, being assigned, okay, um, you know, I wouldn't be able to take it out. I would have to put it in another port group that I wouldn't want it in because I don't want to share that interface with that. It's like a nothing port group from the perspective that I just explained it. So let's go back, and here's the home network, okay, all right, and that's why I do that, okay. Um, I think ESXi just named it network, or network one, maybe something like that. I don't know. I changed the name. So, okay. So now our devices are physically set up. Okay. And now we are going to go into Notepad. Bring up the diagram. Notepad. We're going to start here. Okay. Now, first, I'm going to say this is the configuration for router 1. Okay? Alright? And from the user exec prompt, okay, I'm going to say enable config t, okay, host name, router 1, okay, line console 0, okay, logging, okay, synchronous, alright? And also, before we do that underneath here, okay, we're going to say um, no IP domain lookup, okay? Because nothing's more annoying than you typed in the wrong command with the syntax aspect because you fat fingered something or whatever, and it sits there and tries for a minute, okay, scrolling up trying to resolve that name because it thinks you just typed in the actual domain name, okay, annoying as hell. All right, so we don't want it to do that. All right, you type in the wrong command via a syntax concept, okay, it just goes back to the console, okay. So I believe we have what we need there as far as our also maybe um no exact timeout. All right, I can't remember if I had to put timeout 0 or no exact timeout. It doesn't matter. Okay, so if it doesn't work, it doesn't work. Now, let's see. Okay, so interface G1, okay, IP address 192.168.1.1, okay, 255.255.255.0, okay, and then no shut the interface. All right, okay, and then we're gonna go ahead and copy this, boom, and then G2, okay, and that's going to be 2. Okay, that's wrong. Okay, all right, we're always updating our diagram, remember? 2 5 4 3. Okay, good. All right. So we're gonna say 192.168. All right. Dot 2.1. No. Okay. All right. So that. That's wrong too. So let's make this. Let's make this 10.1. Okay, so let's go up here. No, 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 no. No, what are you doing? What are you doing? What are you doing? I'm screwing up here. 2.1. Okay. All right. So now this goes to 2.1. Okay. All right. And then that's it. Okay. We're going to create our line here. All right. We're going to go ahead and copy this. Copy. All right. This becomes router 2. Okay. All right. All this is, the only thing we need to change is the um, IP addresses on interfaces. 1.2 and 2.2. Okay. All right. And then, all right. And this is router 3. And we need to make this a little bit longer so when I paste, I can make sure that I'm going to the next number. Okay. So this is going to be, first of all, we get rid of this. All right. And then interface 2, G2, is going to be 2.3. Okay. All right. And then, all right, router 4. All right. No, router 4. All right. And then G2. And that's going to be 2.4. Okay. And then 5. 5. Okay. Now we're going to shorten this so we can see both interfaces of 5. Okay. Get rid of that 4 there. 5. All right. And then G1 is going to be, or G2 is going to be 2.5. And then G1 is going to be 3.1. Okay. Go down here. All right. 6. Okay. I'm going to do a Control S to save it. Okay, just in case, because I don't want to have to do it twice, just in case I close the window. Okay, so we're at a 6G1 is going to be 3.2. Okay, and then G2 is going to be 4.1. Okay, and then number 7, which is our last router, and G2 is 4.2. Okay, all right. I'm able to do this the way I just did it in Notepad because of history. Okay, I've done this 1,000 times. Okay, I even use this as a skill set in production, meaning that I'm working for a company doing my job. Okay, so I just taught you something. It's pretty cool, but it takes time to get to that speed, and you don't have to be speedy. Okay, it's the concept of getting it all written out and showing you how powerful a diagram really is. Okay, so now I'm going to just save it. Okay, or Control S. Okay, now I'm going to bring this up here. Okay, all right, and slide this over. Okay, so that'll kind of work. Okay, so now I'm going to go to let's go back over to here. Okay, so if you're using uh, this, okay, in order to telnet to your ESXi device, okay, with these VMs, okay, from a CLI perspective. Give me a second. Okay, that means I want to use PuTTY or a terminal window, not using the console inside here with our VMs. Okay, I have to actually create a new serial port. Okay, or add a new serial or add a port. Okay, and the syntax is telnet colon / the IP address of your ESXi server and a colon and whatever port number you want to use. Okay, now remember this is telnet. Now, I also have to go into I have to start it. I gotta bring it up and run. Okay, let it boot and go into the open console. Okay, wait until it boots. Okay, all right, and then go into config T, okay, and type in platform console serial. Okay, what that's going to do is two things. One, okay, if you don't type this command in for each router, virtual router, okay, or ASA or whatever, you will not be able to telnet from PuTTY or any other program to your VM, your separate VM. You can't. Okay? Alright? Second thing, alright, in the console of ESXi that we're in right now, that you're looking at, it's never going to come to a console port. I'm sorry, it's never going to come to a command prompt. It's going to kind of look like it's stuck booting. Okay, and that's not the case. Now, let's go into Secure CRT. Okay, this is CS01. Alright, as I do my configuration and create a telnet session, notice that I have the IP address and the port number, okay, in there that I defined in the ESXi. Okay, see? Now, from the open console, alright, whatever you're seeing in Secure CRT is not showing up here, okay, in this window, because that's all you're going to get. From your perspective, while you're in the ESXi console of that VM, it looks like it just stopped booting, and that's not the case. Okay, it is now at that point sending the actual messages to the serial port. Okay, as if you created a bridge of the serial port of this virtual device to a PuTTY window. Okay, or in that case, Secure CRT. All right, does that make sense? So that is a must if you want to telnet. Okay, all right, it's a lot easier for me to do it this way. Okay, and that's the way I like doing it. All right, so let's go to our server here in our virtual machines, so we can go ahead and select, okay, all of them at once and power them on. Okay, done. All right, now I can go over to here and select these, which 7's not going to be there. Okay, stop that. Okay, all right. I guess 7 is there because I started 7. And yeah, in my diagram I do need 7. Okay, now 7 might be an issue because I don't think I actually. I don't have to stop that one. So let's go ahead and stop that. Power it off. Okay, go into here. All right, and delete these devices with your interfaces. Go back in here and create 2 more. First of all, I only need 2 for my for what I'm doing. I could put 3 back in there, but Okay, I guarantee you that the first interface in those three, as it was installed by default when you created the VM from an OVA file, I guarantee you network 1 is not G1 in the Cisco CSR device. And that's annoying as hell. Okay, because you're going to end up going into G1. Okay. Um, okay, so you're going into G1 from the CSR perspective, but it's not G1 because you left the default interfaces in there. Could be G2. So when you put that in a particular port group, okay, you're putting the second interface when you think it's the first interface. Okay, so now you are not a point-to-point link with the device that you think you are because you're using the wrong interface. So I like to delete the interfaces and create new ones because every interface you create will make it network one. NIC one is G1. All right. Okay. So just giving you that information. Okay. They could have fixed that in ESXi. I don't know. I can just tell you that a lot of things that I do today, okay, is from things that I learned 10 years ago, all right, when I first started this path, okay? Now, when I say 10 years ago, I mean technically it's 16 years since I've been doing this, but at the same time, okay, all right, some habits are not going to die because you had spent hours trying to figure something out and not days. Okay, and in your mind, you want to make sure that that mistake is not happening again. So I could be deleting those interfaces and redoing them based on habit, but it doesn't really matter. Okay, because in the end result, those 30 seconds of me doing that, okay, allows could or could not make a difference. All right, but you're not killing time like that. Who cares? 30 seconds. All right, you're not really killing it. All right. And at the same time, I can always go in there and create the default interfaces and go in there and test it. But again, by the time I do that, okay, it might come into another version where it goes back to that. The bottom line is that extra step, okay, does not hinder my time frame as far as well. I spent hours doing this, creating new interfaces. So I could have spent that hour studying. That's my point. Okay, so a lot of things we do, and in life too. There's a lot of things we do in life that we don't have to do. Is pointless. Always have been pointless. But this is the habit that we created. Okay, sometimes that habit is bad for your health, and you're always saying to yourself that it's good, okay, because as time goes on, things are updated, and we have not done that research on that particular issue in over a decade, okay. At the same time, it never made a difference. Does that make sense? Okay, so hang on. Okay, so another thing I want to mention is the fact that when you're in a console here, from a success perspective, okay. It takes a little bit. Okay, so obviously I'm not gonna get to a console because I actually have the platform console serial. Okay, but what if I did? Okay, right clicking isn't really that easy because your mouse is now inside this console. Okay, and you don't have a mouse. Does that make sense? So because it's a terminal window. All right, now if I was in a Windows console, okay, going into each one of those consoles to make changes in Windows is fine because Windows has a mouse, okay, but there's no mouse here because it's a terminal window, okay. So unless there's a keystroke, okay, for you to paste, okay, or right click to paste, or even bring up a menu, okay, you don't have that option. Where in a terminal window, okay, all right, I can see that I can paste all day by hitting right click, okay, and another thing, I can create scripts, okay. All right, I can say start recording and just come in here and just start typing, and whatever I type is recorded and put into a script. No code needed. You go back into the script, stop the recording, okay, and you're done. Now, this is perfect. It even it records whatever you're doing and makes it into a script. It puts the code in there for you. So that means you have 20 character password. Okay, so you're at work, you have secure CRT. All right, you put those characters, those 20 characters, in the actual command prompt as it's asking you for the password, and it's recording. Okay, and that goes into the script. All right, so now your login for that device, okay, is to run that script. So not only does it telnet or SSH to your device, but it logs in for you and brings you to the prompt. Okay, period. All right, you did nothing. All you did was double click. Okay, there are buttons down here. Okay, that you can create. All right, I can actually right click now because the buttons aren't here, but you can create buttons to do things like show interface brief. Okay, all right, so that stops you from having to type that command all the time. Just hit that button and it shows up here and it runs. All right, I can also say hit command for all sessions. Okay, that's beautiful. Okay, all right, so now, Putty, unless there's another version of Putty that I don't know of, because I don't use Putty anymore. Okay, I haven't used this since like 2011 or 12. Okay, since I've discovered Secure Certi. Um, I don't think you have the ability with newer versions of Putty unless there's a Putty that has come to surface that allows you to do tabs. Okay, I know there's like a emulator third party one that does tabs for you to telnet SSH in. It was pretty cool. I think it was called like Window X, um, or Windows something. I can't remember what it was. Again, I started using that before using Secure CRT because I could put my stuff in tabs. But if they're not in tabs, okay, just like any window, let's say this is actually a terminal window, okay, just have the corners coming out this way and having the bottom of it always being bigger or wider or longer and a little bit wider than the previous window that's behind it. Okay, so you can just click, 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 okay, and easily go between your devices. Also, multiple windows are fantastic, okay, and in fashion if you are using debug commands, if you are trying to find out what's going on and you want to see both routers live, okay, you can put them side by side, okay, all right, watch both adjacencies come up, okay, all right. It's also good for comparing configs and output of logs. Okay, so the benefits are there. Okay, all right. And also it comes down to preference. Okay, as you can see what my preference colors are, those are my preference. Okay, so now we can go to router one. Okay, I hit enter a couple times. All right, to bring up a prompt. Okay, if you have the explanation part, that means something has happened on the device as you are not focused on that window. Okay, now I'm focused on the window because I clicked on it and it goes back to a check mark. Okay, something happened in the background, which obviously I had enter a couple times and it didn't register until after I went off that window and went to another one. Make sense? Okay, so now I could also came here and say send commands to all windows. Okay, all right, clear the screen with a bunch of enters and see what it did to all of them. And notice how all of them turned with explanation parts. And now we're back to, okay, so pretty cool, huh? So now, we are going to copy this, okay, and go to router 1, done. Router 2, copy, done. Router 3, copy. I'm hitting Control C to copy, by the way, just in case you're curious. Okay, router 4, Control C, boom, copy, Control 5. Router 5, Control C. All right, that's very easy to do with the Control key. I had the Control key still there. Okay, so now router 6. Okay, and router 7. Okay, so now, okay, I shorten this a little bit so I can see what I need to see. I'm gonna go to the router 1, okay? As a matter of fact, I'm gonna go to all this and type in N to bring me back to this prompt, okay? That means now every session is back to that prompt. Cool as hell, huh? Okay? So remember, that's a right click and says send commands to all sessions. And be very careful with that command, okay? Because I've seen people, okay, all right, have multiple sessions in. One was a lab one was a production one, and forgot that he had this selected and hit reload and reload the production device. Now, I've never done that, but don't think that I have not rebooted things that I shouldn't have rebooted, like core switches and stuff like that, because I have. Okay? All right? By having a lab environment, okay, and having the core up in 2 different sessions in the same color font, okay, and accidentally rebooted the actual core switch by mistake, thinking it was my lab one, okay. Very easy to do. Very easy. That is when it dawned on me. Well, now I need to figure out a way never to do this again. Okay. All right. Mistakes happen. Yeah. Okay. All right. And you're gonna feel bad at doing that and feel like an idiot because you give a shit. So don't worry about that. It'll pass. But don't do it again. How do you not do it again? Well, now anytime that I am doing production with a lab, okay, where there is that chance, my lab would now be in red letters instead of yellow. No, so I know that red means no, stop. Okay, this is your production device. Okay, see, and that's the thing. Okay, all right, something so simple you would never think of, and then when I tell it to you, you're like, oh my god, that's awesome as hell. Okay, that's why having control is the power, okay, that we have when it comes to managed devices, where we have to manage them, okay? All right, so now our configurations are done. In the beginning of your training, okay, like a CCNA candidate or whatever you want to call yourself, okay, like I called myself for years, and I mean many years, the network novice, because that title I was not going to change until I had accomplished my goals, until I felt inside, true in my heart, that not only am I no longer a novice, but I can back up. I can talk the talk and walk the walk. All right. I'm not saying you have to do the same thing. I would encourage it. Okay. All right. And God, I mean, like, dude, when I say for years, I'm doing CCIE stuff, calling myself a network novice. You see what I'm saying? Okay, that's only your own personal growth. It is your responsibility to make you who you want to be. Okay, all right. Just do me a favor. Just really think about what you want to be, and um, and make it have some type of integrity for yourself, not for me. Okay. So now, or for anybody else. So now we're gonna go into because now all our configurations are done from a layer 1, layer 2, layer 3 perspective. So I should be able to go to router 1 and ping 192.168.1.2. Now, two things. Okay, the first ping failed. Okay, all right. Let's go over to router 2. We haven't done any pings yet. Oh, did I forget to do? Oh, I forgot. See, I forgot to change the host name. Oops. Okay, so now let's do this. I'm going to all consoles, right? I'm going to say config T, okay, and say host name, okay, R. That's it. Okay, why did I do that? Because now, okay, when I go back to each one, all I have to do is hit the up arrow key, okay, because that command, since I enter, is now a history. Yeah, you kind of like that, don't you? Okay, All right, little tricks that you learn throughout time. Okay, um, and trust me, I'm happy to teach you anything that I can do. All right, so this actually slows down time. Okay, um, now you can go through your entire career. Okay, all right, and so now we're gonna go into here and say end and then write the configuration. Okay, so now it's saved. So you can go in your entire career, okay, and never become this efficient, and it doesn't really matter, okay, because what I have done doing something like that, all I did was shave off how many seconds, okay, all right, it doesn't really matter, no, because really shaving time off, okay, kind of increases your method of losing focus and making mistakes. But at the same time, you gotta understand why this has become something important to me, because as a CCIE person, okay, these are the little things I was trying to do to shave seconds and time off to change configurations like that. And when you have 20 routers in your lab, you might have 8 hours, but I'm telling you, 8 hours is not enough. Okay, so doing these little tricks is something that I have embedded into my habit for that purpose. And it's become, as a byproduct, a resource. Does that make sense? So you don't have to be that person. You see what I'm saying? Okay, to be the fastest person. You know, your objective is to become and try to and plan 100% accuracy, and maybe you get 80 to 95. Okay, but you're going to get mistakes. So nonetheless, okay, notice, okay, our first ping failed on this one. Okay, and I have an ARP table. Okay, so 2, show ARP. Okay, I have an ARP table there. Let's take a look at 3. Okay, no pings have done. Show ARP. Okay, now this was never intended for this, but we're going to discuss it. That router 1 and 2, okay, has a ARP table. Okay. Now, I said here on router 2 that there was no pings being done, but that's not true in theory. Okay, and I'm going to tell you why. When you send a ping, okay, remember, what do you need for communication? The 4 things you need: source IP, destination IP, source MAC, destination MAC. We got a MAC address table, okay, all right, and we have an ARP table. The ARP table relies on the fact of binding an IP address to a MAC address, okay. If I do not have it in my ARP table, okay, my communication for that ping will fail, which is why the first one failed. Because in that first ping, I don't have it in my ARP table. So now I'm going to send out a message saying, hey, I'm trying to find out for 192.168.1.2 what your MAC address is. And now MAC address 2, as it sends a response to router 1, now your traffic's coming to the other way. And now you got to look at it from the perspective, now I got to make sure that I have whoever sent me the ARP request, that I have his MAC address in my table, because I will never be able to send a reply back without having those 4 bits of information: source IP, destination IP, source MAC, destination MAC. So that means I got to build my MAC address too. So during that time, as these two are negotiating and building their MAC address tables to communicate back and forth, because router 1 sent the request because he didn't have it in his MAC address table. Router 2 is trying to send a reply, but he has to have it in his MAC address table. Okay, and what I mean in his I'm sorry, in his ARP table. Okay, all right. Sorry, I'm saying that long. So let's stop. Start over. Router 1 sends a destination ping to router 2, but does not have the destination MAC address in its ARP table. So it sends out an ARP request. Router 2 gets that ARP request, looks at the packet and says, this is destined for 1.2. I am 1.2, okay, and since router 1 put his MAC address in the original request, now router 2 has to update its ARP table just so he can send a reply back. Okay, otherwise router 1's not going to get the reply because the encapsulation of our layer 2 information from router 2 is going to fail. I hope I said that a lot better, which I believe I did. Okay, so during that time, router 1's first ping timed out. He did not get a response. Okay, the first ping, okay, and TCP/IP, or the ping protocol, I should say, the ping protocol reached its timeout before it could get before it ever got a ping response. So you got two different things going on here, and they're both two-way communication. You need to understand that. In order for me to have a successful ping, router 1 had to update its ARP table, router 2 had to update its ARP table, and router 2 had to respond to the ARP request. During that time it took to do all that, okay, the first ping failed because it timed out. Timeout means you only got so much time to get a response before I'm going to the next ping. Because that particular ping in that moment in time has timed out. It reached its timeout period and it failed. I gave it time. Okay? Alright? So every time you ping something for the first time, 9 times out of 10, your first ping is going to fail due to the ARP population of your source and destination, okay, from that aspect. Alright? Especially if you're on the same broadcast domain. Alright? Now, okay, with that being explained, okay, so now we can go to router 2. Let's say ping 192. Now we don't have to ping 1.1. We also got to understand, if I ping from router 1 to router 2, going through all that process I just explained, we have literally determined that there's a two-way communication from router 1 to router 2 because our pings responded. So if I ping from router 1 to router 2, I have to go to router 2 to ping 1. I've already proven that two-way communication is stable. So we're just going to go to the next one. So 192.168.2.1. Okay? Now, from this perspective here, okay, from here to here and here to here, it's proven. I'm done. So now I'm going to go to 2.5. Then I'm going to go to 2.4. Okay, and 2.3. Okay, so what this is telling me is this. If my communication from router 1, 2 to 5 is up and it works, that means my interface is up, it's live, it has an IP address, okay, there's an actual ARP entry in its table for me, okay, so my communication as far as all my devices communicating on this broadcast domain from my perspective is fine. Okay, I'm not going to go to every router and ping. I could go to router 4 and ping 1.2.3.4. I mean, at 5, if I wanted to be that thorough. Okay, but from my perspective, okay, if router 5 can reach router 2 and router 2 can reach router 5, I'm sure router 5 can reach 4, 3, and 1 because I've tested possibilities that on the OSI model, things are working from router 5's perspective, and router 4 and router 3 if I'm able to ping it from router 2. So from my perspective, without going to every router and pinging every address, from my perspective, that knowledge is fine with me from a starting point. If I get later on into my lab and communication is not working, then I can go through those particular devices that I'm having a problem with. Like if I can't communicate between router 3 and 4. Now, as a novice, okay, I would recommend you go into every device and pick them all because there's no question then. All right, okay. My level of thinking, okay, is due from the concept of knowledge that I've obtained throughout my path here or my journey here as an expert. Okay, all right. So and it does not it does not mean, okay, it's the right way. I'm just telling you, okay, if you want to be sure, then you go to every router 1, 2, 3, 4, 5, and ping every address on that subnet. You see what I'm saying? Okay? Alright, so if you're confused about how I explained that, that's fine. Then default back to pinging every address on every router, and you won't have a problem. Trying to understand my logic of why I did it the way I did it, and you're not getting it, this is going to make you have more problems. Stick with what you know until you evolve. Okay? And at that point, when you evolve to another level, stick with what you know. Okay? All right? Until you have a deeper understanding. All right? And still, even with that deeper understanding, stick with what you know. All right? Okay, so router 5, okay? All right, we're going to ping 192.168.3.2. See how easy it is for me to just to look at it and not have to guess? Okay, so now we go to 6, okay, and ping 192.168 dot 4.2. Okay, so now you see that every hold up. Okay, so show up interface breathe 4.1. Let's go over to here. Okay, so let's go check our port groups because something is not. Oh, you know why? I already know what it is. Nope. No, I don't. Okay, so let's go over here and make sure our port groups for 6 7 are correct. One is 3. This is 4. And this is not. This is in home network. Okay, so let's put this on to VLAN 4. Layer 1 is broken. Okay, so now let's go back over to here. And there we go. We're fixed. Okay, so everything is good. We're going to go ahead and write the configuration. All right, every one of them is saved. And now, we are going to go and type into every one of these consoles, okay, IP router OSPF, and give it a process number, which is only significant to the router itself. They don't have to match. Okay, and we're going to say network. Oh, I'm trying to tab it. Network 0.0.0.0. Do I have to put something in there? Let's do it this way. Let's go into here and say network 0.0.0. Yeah. Okay. So the wildcards. Okay, and then I'm gonna say area 0. Okay, and done. I'm gonna go ahead and copy this because it's only on one router. Paste. Okay, so now all the routers are enabled with OSPF. Okay. Now we're going to wait and see what happens. Because first of all, OSPF takes its time. Okay, as we saw in the other video, let's bring it up in adjacency. That's 1. 2. Okay. There's a couple things of doing this method that you're going to have an issue with. First of all, okay, are we doing a DR and a BDR election? Okay, all right, that's an issue. Okay, that will slow you down a little bit. Okay, see how the adjacency just came up for router 2, and I guarantee you for all of them. Okay, all right, and you got to understand what. Why do we need a BDR elections? And don't forget we have OSPF network types. Okay, in this domain here for VLAN 2, okay, I don't want updates. If a link comes up, a link goes down, I need to send an update to make sure my table is accurate, okay, or my database, which we're going to take a look in a second. Now, so I'm going to have a DR and a BDR. The backup is a designated router. Okay, the DR is a designated router. Okay, so on a particular multicast address, anytime, okay, that I need to send an update, I'm not going to send it to every one of my routers, killing my bandwidth. I'm just going to send it to the DR. And the DR is going to send it to another multicast address that all the OSPF routers are listening to. Okay, so that means I have one-way communication from router 5 up to 1, and then from 1 out to 3, 2, and 4. No point to send it back to 5. Does that make sense? Okay. All right. Even though 5 is probably going to get it because it's going to be listening on that multicast address, but it doesn't matter. All right. Okay. So 5 sends an update to 1 because 1 is a designated router. Router 2 is a backup designated router. Okay. Assuming in our example. Okay. And now when I have to send information back, router 1 just sends it to unicast address, multicast address to router 3, 2, 4, and 5. Do you not see how easy that is? Instead of router 5 saying going to router 2, 1, 3, 4, and then 3, 4, 2, 1, sending out confirmation updates saying, yeah, I got it. Okay? All right? Assuming that's what it does. I'm only saying that from the concept is, okay, all right, the confirmation will be, all right, you know what? Just forget I said that. Okay, I'm just making it extra complicated. All right, so now, okay, so the BDR only becomes a DR when the DR dies. Okay, all right. So now, when the DR dies, okay, the BDR becomes a DR, and then we have another election for the BDR. Okay, does that make sense? But it really, we don't need all those messages going back and forth in a large OSPF environment. Okay, so now our lab is still not set up correctly, but we're going to actually um, tweak it. Okay, all right. Now, what I have done is sending that command network 0.0.0.0 says enable OSPF on all interfaces because the network, okay, to be specific, if I would have said network 192.168.1.1 wildcard 0.0.0.0, that's saying only enable OSPF on the interface, okay, of that interface, okay, meaning that I'm only doing OSPF on its interface. Now, show IP OSPF interfaces. Okay, oops. Is it a brief? Yeah, it's a brief. Okay, so now with one command, router 2.1 has OSPF enabled on both interfaces. Once OSPF has an interface, okay, all right, which we're going to go through by disabling this command, okay, and we're going to do it on a specific interface by interface thing. Now, we gotta see. Look, router ones, G1 and G2. Okay. All right. G2, I'm sorry, G1 has BDR. Now, you got to understand, BDR, DR and BDR elections are used in a broadcast environment, not a point-to-point. Okay, so if I see a point-to-point link, okay, come on, come on, stop. If I see a point-to-point link, and I know it's a point-to-point, and I see BDR, that means the other point-to-point connection is the DR. Like if we go over here to router 2, okay, it's the DR on G1, okay, but it's pointless because why have a DR and a BDR to move update traffic when there's only two devices? Okay, my neighbor is going to get it because it's a point-to-point link, and it's extra bandwidth being utilized. Pointless. So we got to make sure our point-to-point and our broadcast network types are accurate. So as we go up here, let's go back to here. Okay. Actually, we need to go back up to here first. Okay, and then I'm gonna go all the way back here because we're doing this for all sessions. Okay, now they're brought down. Okay, as you can see here, OSPF went full to down, and now we're going to do this correctly. Okay, all right. So I'm in router OSPF. Okay, and now I got two ways of doing this. I can say network 192.168.1.1. My wildcard is going to be all zeros because I want to match that particular IP address. Okay, area 0. Done. Okay, now I'm gonna go over here to router 2. Okay, after copying this and do the same thing. Okay, and then I'm going to say 1.2 because that's the neighbor of. Oh wait a minute, hold up. That's the interface of G1 on router 2. And now let's see what happens. Okay, so as I'm looking at the screen, okay, I have a typo here. So that's never going to work. Okay, so let's go up. Control A to bring to the beginning of the screen. Say no, not mo, but no. Okay, and then type in the right IP address, which is 192. Okay. And take the no out. Sorry, I just realized what I did. Okay. Now, the second I do that, okay, that interface gets enabled. We're in the waiting state. Remember our states, okay, and all our like Xstart and loading and all that stuff, okay, that we learned, all the stages of OSPF, okay. To really see this is show IP OSPF neighbors, okay. There's no neighbors there, so looking at the interface, okay, show IP interface, interface G1. Okay, now we can see from the perspective of what's really going on here. Okay, all right. It tells you that that IP address is in area 0. Okay, Okay, and it's a broadcast type, which is definitely incorrect because it's point to point. Okay, and it tells me what our router ID, which we're not going to discuss at the moment. Okay, so now uh, show IP OSPF neighbors. Okay, nothing. Okay, so show run router up include section. Okay, so 1.2 show IP OSPF interfaces. Okay, so 1.2 is it. Okay, and let's make sure that we can ping the damn thing first. Ping 192.168.1.1. Okay, so let's go to the router and let's see what we did here. You did the same thing because you copied it. Okay, so let's go back here and say no. Oops. That's the problem with copying. You copy your mistakes. You paste your mistake, right? Okay. And there we go. Okay, now this came up really fast, even though with the BDR and DDR elections, because the adjacency was already formed. Okay, so on and so on. But we also got to look at here. Okay, all right, and I want you to understand. All right, look how long it took us to bring that up. Okay, the troubleshooting wasn't an issue. All right, because I've done this a thousand times. Okay, but as a person who's just starting, oh my God, it could take you hours just to bring up an adjacency. That's why you need to know all these working parts. Okay, your MTU is wrong, you're not going to form an adjacency, and I'm talking about they're not the same between each other. Okay, router 2 and router 1 has to have the same layer 2, not layer 3, but layer 2 MTU. Okay, actually, I don't even know if the layer 3 MTU matters. I've never um, and in order to change that, you have to go into the interface and say IP MTU. Okay? Um, because you're going to be changing the layer 3 aspect, obviously, because you're using IP MTU and not the layer 2. Now, um, um, let's see. Okay, so now we got show IP OSPF neighbor. Okay, now our neighbor is formed. Okay? Now, does that say 2.2? Oh, okay. So we're not going to talk about the router ID at the moment. I'm not going to worry about that. We'll worry about that later on. Okay. But we're going to actually go in here, show IP OSPF interface um, G1. Okay. This is broadcast. This is incorrect. Okay. So now we're going to go into here. Interface G1 and say IP OSPF. Okay, now from this perspective, check this out. I could say OSPF 1 and then say area 0. That is the second way of enabling IP OSPF on an interface itself and still don't worrying about the network command. Isn't that so much easier? IP OSPF 1 area 0 under the interface. Bam. Okay, that interface is enabled for OSPF. Okay, so much better than the network command. All right, and we're going to use that from here on out as far as our example in this video. Okay, so now, but IPF OSPF network type, okay, is going to be point to point. Done. Okay. All right. Now, why am I able to form interface brief? Okay. Notice that my state is a point to point, but over here, OSPF interface brief. This is a DR election. Well, that's kind of weird because I got a DR election here on router 2, but router 1 did not become the BDR because it's not trying to do an election because it's point to point. And why the hell are we able to form adjacencies? Okay, and that is because if we look at OSPF interface, okay, you can see here, even as a broadcast type, our hello and dead timers are the same, 10 and 40. Let's go over to here, okay, 10 and 40. That's why they were able to form. But this is not good, okay? All right, so we need to go into here, okay? Interface G1, IP, OSPF, network, point to point. Done. Now, show IP, OSPF interface. Oop, brief. And now, that is the correct method of creating a OSPF adjacency, okay? All right, in the correct fashion, okay? Now, with router 3, 4, 5, we're going to do it this way, okay? Interface G2, okay? IP OSPF 1 area 0. Done. I'm going to say a do show history. Now remember, when you do a show history, okay, if you do the do show history in config T, you're going to see the history of all the things you put in config T mode. If you do it in pound mode or a privilege exec mode, you're going to see the history of that mode. So they're not interchangeable. Okay, so now I'm going to say this, okay, and then I'm going to go to 3, 4, and 5. Okay, 3. Okay, what? I wait a minute. Hold up. I did this on 3, so now I need to go over to 1. Okay, and I did not need that last thing. Okay, and then I have to go into config T. Done. I don't care if the history actually runs. Okay, and 5. Okay, so now they're all up and running. Okay, see? Now let's go in here. By default, because it's an Ethernet interface, by default OSPF is going to put its network type in broadcast. Interface brief. I had to think about it for a second. Show IP OSPF. Okay. All right. Now, DR other. That means it's not a DR and it's not a BDR. Okay. All right. So who is the DR? So let's actually go into all of them and say show IP OSPF interface brief. Okay. Well, router 1 is a DR. Router 2 is not either. Router 3 is a DR. Okay? Now this is fine because if I say show IP OSPF interface, okay, each one of these are type broadcast, and that's what it is because we're in a broadcast domain. All right? Okay? And okay, and each one of them are going to say that, and our hello and dead timers are the same. Okay, so we are good as far as OSPF. This is correct. Okay, now let's go over to 5 because 5 is going to be different. All right, now 5, we have an interface in area 0 and an interface in area 200. All right, now because of that, And you know what? This is actually, this needs to actually come down here. Okay, so that's not gonna work. So let's I'll fix that later. Okay, so now we're gonna go into interface G1. Okay, IP OSPF 1 area 200. Okay, all right, and IP OSPF network type point to point. Done. Okay, and then we're going to go ahead and ping 192.168.3.2. Okay, just to make sure that we got connectivity there. We're going to go over to router 6, config T, interface G1, IP OSPF 1 area 200, IP OSPF network type point to point. Okay, so now adjacencies is formed. Okay, so now do show IP OSPF interface. Okay, and now you can see this is a point to point link. Okay, and hello dead timers are the same. Okay, and do show IP OSPF interface. Okay, same thing. Okay, now there is no OSPF adjacency between router 6 and router 7. Okay, all right, and I need to physically change the diagram to move that router in between those devices. But okay, that is the lesson of setting up multiple areas in OSPF. Okay, in our next video, we're going to talk about the database. So that means we're going to erase all this configuration and do it all over again. But I want you to look at this from a configuration perspective. Okay. If you're stuck in a more concept, okay, you can hit enter to bring up each line. To do a page at a time is space, and to get out of it is backspace. Okay. All right, just to let you know. So show. What was that? What was I going to talk about? Oh, show run section OSPF. Okay. Now, this is being pulled, but not under the router OSPF part. This is under the interface, and it's not going to show you what interface it's under. Okay, that kind of sucks. But then again, okay, I only want to see the OSPF information as far as the router OSPF. Now, the best way to look at this is to find out is our show IP OSPF interface brief. This is going to show you what they are, what error they are, what their states are, and what interfaces are enabled for it. Okay, so show IP OSPF interface brief. Okay, as you can see, okay, they're in area 0. But when we go to router 5, okay, okay, you can see that one is in 0 and one is in 200. That makes it an area border router, right? That's why the placement of this router I put in between, because to show you that we are in between areas. We're an area border router. Okay, same thing. 6 needs to be kind of here to give it better visual aspects. And like I said, I'll fix that later. Now, okay, so if looking at it from this perspective, this is so the best way to look at your interfaces that are enabled and how they are looking. But from a network perspective, as far as router OSPF network, okay, now if you're looking at the configs, you have to go back and find out what interface is under here. Okay, or I can do a show IP interface brief, okay, which tells me nothing. But if I do a show run, and start looking at my interfaces, okay, all right, I can see now OSPF is enabled on that interface. Okay, does that make sense? Now this went here and because we did the for all commands, right? So it doesn't really matter. So now, oh no, we didn't. I think this we did separately as well. Again, it doesn't matter. Okay, all right. So we have now gone through the concept of creating OSPF in a logical fashion. Okay, it's not just enabling on the interfaces. We got to make sure our hello and dead times are the same. Our network types are correct. We're in the correct area. Okay, all this makes a difference. Okay, you got problems. Okay, all right. You need to check your MTU. Okay, if you're stuck in this stage. All right, you got to make sure that your database is being loaded. Okay, all that stuff, which we're going to talk about in the next video. For now, be strong, be determined, be Cisco, and I'll see you guys when I see you.